Hello everyone, welcome to my YouTube channel. In this video, we will solve equations from JEE Advanced 2023. The question is given that let f is a function defined as fx equals to root n, where x lies between this interval, and let g be a function such that g lies between 2 root x to this integral value for all x in 0 to 1. Now we have to find the limit fx into gx, limit x tending to 0 fx into gx. Now how to think this type of questions in examination hall? See here, we have not given any exact value of g of x, so we can't multiply the fx and gx directly and then take limit x tending to 0. So how to think in this type of questions? Let's try to find first the individual limit of fx and dx. If the individual limit of fx and gx, limit x tending to 0, this fx and gf both are finite, then we can multiply both of them and then we'll get the answer. Let's try to find the individual limit of fx and gx. See first, what is the individual limit of f of x? The limit x tending to 0, f of x is root n, where x lies between this interval 1 by n plus of 1 to 1 by n. Now see, when x tending to 0, this n, that means n tending to infinity, so this limit will goes to infinity, so we can't multiply. Even if the gx is exist, the limit of gx is finite, then we can't multiply fx and gx since fx is infinity, so this method is not applicable. Let's think in another way. What we can use? See here, gx is given in terms of an inequality, so now we will try to find fx in terms of inequality, so that we can multiply fx and gx and then we will apply sandwich theorem. We will try to find the range of fx in terms of x. So here given x in x less equals to 1 by n plus of 1 and strictly less than 1 by n. Now if we take the reciprocal, then the inequality will change. So if we take 1 by x, this will be greater than equals to n minus of 1 and this will be n. Now from here try to find the range of n. So here n minus 1 is greater than equals to 1 by x, so that means n greater than equals to 1 by x of minus 1, and from this to 1 by x is greater than n, that means if you combine this and this, we can write n, this is greater than equals to 1 by x of minus 1 and this is less than 1 by x. So now take square root. 1 by square root of x is greater than equals to square root of n is greater than equals to square root of 1 by x minus 1. Now what is root n? Root n is f of x, so we can write here f of x. So 1 by root x is greater than equals to f of x is strictly greater than, not greater than equals, which is greater than equals to square root of 1 by x minus of 1. Now we can multiply fx and gx. Let's see what is g of x. G of x is integration x square to x square root of 1 minus t by t dt strictly less than g of x strictly less than 2 root x. Now we will multiply fx in this inequality. So this is f of x and g of x. This square root of 1 by x minus 1 will multiply here square root of 1 by x minus of 1, and this integral x square to x square root of 1 minus t by t dt, and here 2 root x and will multiply this 1 by root x. For f of x it is 1 by root x. Now see, root x cancel. So this is 1 by x minus of 1 integration x square to x square root of 1 minus t by t dt strictly less than f of x into g of x, and this is less equals to 2. Now we will try to find the limit here. If limit x tending to 0, this limit goes to 2, then by sandwich theorem we can say that limit x tending to 0 fx and gx is 2. So let's try to solve this. So limit x tending to 0, this is square root of 1 by x minus of 1 and integration x square to x square root of 1 minus t by t dt. This we can write it 1 by x minus of 1, we can write it 1 minus of x by x. Now here if you put limit x tending to 0, then this is infinity and this is 0 to 0, infinity into 0, indefinite form. So we can't apply directly limit here. So we will try to use the L'Hospital rule here. So how we will use this? We can write this as limit x tending to 0. This is integration x square to x square root of 1 minus t by t dt, and this term we can write as square root of x by 1 minus of x. Now apply L'Hospital rule. So limit x tending to 0, limit x tending to 0. Now differentiate this. How you will differentiate? Using Leibniz theorem. So Leibniz rule is first put x in place of t and then differentiate of this. So square root of 1 minus x by x, and differentiation of x is 1 minus put x square in place of t, this square root of 1 minus x square divided by x square, and then differentiation of 2x is x square is 2 of x, and now differentiate this. So this differentiation is 1 by 2 square root of x by 1 minus of x, and then again differentiation of this 1 minus of x whole square is 1 minus of x, and then x derivative 1 minus this x into derivative of 1 minus x. The derivative of 1 minus x is minus 1. Now try to simplify this. Limit x tends to 0. Now see here, we can take 1 minus of x by x, square root of 1 minus of x by x as common. So we can take square root of 1 minus of x by x. If you take this common, so here 1 will be left minus here 2x square root of 1 plus x by x, and in denominator we have this 1 by 2 and square root of, we can write it as 1 minus x by x, since this is in this denominator, and we have here 1 minus of x, and this minus and minus, this is will be plus, this minus and this minus will be plus. So this minus x and this plus x will be cancelled. So this will be 1 by 1 minus of x whole square. Now see, this term and this term will got cancel out. So what we left? Limit x tending to 0. So 1 minus of this 2x, and we can write it as this square root of 1 plus x by square root of x, and in denominator we have this is 1 by 2 and 1 by 1 minus of x whole square. Now see, this square root of x, and here we can write it as the square root of x, this will cancel. So limit x tending to 0, we have 1 minus square root of x, 2 into square root of x into square root of 1 plus of x divided by 1 by 2 into 1 by 1 minus of x square. Now if we put x tending to 0, then 0 into this 1 plus 0, this will be 0, this will be 1, this will be 1. So the final answer will be 1 by 1 by 2, 1 by 1 by 2. That means this is 2. So we got 2 less equals to f of x into g of x, which is less equals to 2. So by sandwich theorem, limit x tending to 0 f of x, this is limit x tending to 0, x tending to f of x, g of x is equals to 2. See in which option it is given 2. So option C is correct. Option C says is equals to 2. So option C is correct. Please like, comment and subscribe my channel.